hopefully you've had a chance to look over these and try these for yourself, because remember, your practice helps you prepare for the quiz. So our slope, it says find and interpret the slope, is our rise over our run. So we're going, in this case, we're counting up 2, but what does that 2 mean? It's going up 1,000. So I have 1,000 divided by, and then I'm going over 1, 2, 3 days. Is that right? Is it going up $1,000 every 3 days? So 1,000 divided by 3 is, I'm guessing, a repeating decimal, but yes, 333 and a third is our slope, or you could leave it as this. It really means $1,000 for every 3 days. So this is 333 and a third dollars. We should write it as cents since we're talking dollars, I guess. So we'll round to the nearest cent. $333.33 per day is what it means, what that slope means. Here for number 2, we're graphing this represented by this equation. Remember, all proportional relationships start at 0, 0. So that is actually going to be our y-intercept. And then for every 1, we're at 33.75. Well, that's kind of ugly. That would be about here. For 2, we'd be at about 67-ish. So that's about here. So these aren't very pretty, because this is an awful example of making us do this, but this would go up like this. The slope would be this right here. M is 33.75, which means $33.75 per hour. Remember, it's always y divided by x. So you can look at your labels, dollars divided by hours, dollars divided by hours, okay? If you're not sure what your label is, when you're interpreting the slope, they really want the label. All right, so graphing this, by the end of its 4th week, so we have millions, 9.2 divided by weeks, so 4 weeks. So if I put this in, 9.2 divided by 4, my slope is 23. Is that right? 2.3, sorry, I was like, 23 doesn't make sense. So if it starts at 0, it's going up 2.3 each time. So about here. And then we have 4.6, which is about here. And then we have at 4, it's at 9.2, so it's up here just barely. So this line is going up in this direction. What does that mean? It means it makes $2.3 million per week. That's how we would interpret that slope, what that slope means. All right. Now we're comparing, we're using the slope of A. M of A is equal to that 1,020, right? That's how our coefficient is M. And then here, looking at our graph, it's going up, is that 12,000 more? Up 12,000 over 1. So the slope of B, is equal to 1,200, I should say, not 12,000, over 1. What does that mean exactly? Well, we can look at our labels. Look at our labels. We have we don't have to interpret this, but for practice, we would have power per square meter, which is more solar panel B. So we're going to say panel B is our actual answer. We can explain by writing these out. Obviously, 1200 is more than 1020. All right, so we're going to move on to 4.2 today. And I think this is another one you'll be good at because we've done this. This is page 191. So it's the slope of a line. The term slope is used to describe the steepness of a line. Slope is the rate of change between any 2 points on a line. The vertical change, right, our change in y value is called the rise, while the horizontal change, our change in x value, is called the run. Lots of review for you. So slope is the ratio of the rise to the run. In linear relationships, the slope is always constant. That's our constant rate, right? Slope can be positive or negative. Remember, puff, puff, positive. Nice, negative. That's pretty much it on 191. Turn to 192. We're going to review how we can find the slope by finding the ratio of the rise to the run between any 2 points. So here, from here, we're going up 3. So we write the change of 3 here. That's our rise change. And we're going over 1, 2, 3, 4. So our horizontal change or our run is 4. So 3/4. When reading the rise and run from a graph, a rise up is positive, a rise down is negative. This is important stuff right here. This is what we review constantly and I write down, right? Up is positive. Down is negative. Right is positive. Left is negative. You need to know that for sure. So when we find the slope from a graph, looking at our first example here, we're looking at our rise over our run. So we're still counting. We've practiced this a lot. We would count our rise first. There's 1, 2 here. And we would write it over our run, which is just 1 in this case. So we could call it 2 over 1 or 2. Go ahead and find the slope of this line on page 193. This is page 193. I'm going to give you just a minute. They gave you 2 points, this one and this one. What is the slope? Remember, you're trying to figure out your rise over your run. So hopefully you've done that. If it's helpful, you can write it out. Our rise, we're going up 1, 2. Our run, we're going over 1, 2, 3. So 2/3 is equal to our slope. Fair enough. We remember this, hopefully. All right, so look here. This is the slope of water loss over time. Loss we're expecting to be negative. So our definition of slope is rise over a run. Our rise is -4, so it goes down 4. 1, 2, 3, 4. So we would write that here. Our run is 6. It goes over to the right 6. 1, 2, 3, 4, 5, 6. Now we need to simplify that. So we can divide them both by what? They're even. So let's divide them by 2. So we end up with -2 over 3. So our simplified ratio, or our slope, is -2/3. Remember, we can write it like this, giving the top the negative. We could write it with the negative in front of it, or we could write it with the negative in the bottom. So when you go to graph lines, it's important that you know all 3 of these are equivalent. You can think down and to the right, or you can think up and to the left. okay? So 194, cruising right along here. Find this slope, another negative slope for you to find. Rise over run. So our rise is going down. So we have negative 1, 2, 3, 4. Is that right? Did you get negative 4 for your rise? And our run is positive 1. So this is equal to our slope, or you could call it negative 4. So we know how to find slope from a graph. Slope from a table. This is actually what we did first, right? We found our change in y. Here it's going down by 30. And then we found our change in x. Here it's going up by 3. So negative 30 divided by 3, or we can think of it as simplifying. So we could divide them both by 3. And we end up with negative 10 over 1, or negative 10. So let's look at the example they give us on page 195. Remember, we want our change in y first. So what is our change in y from negative 2 to negative 1? Or negative 1 to 0? Or 0 to 1? What's happening here? Plus 1, right? Or in other words, negative 1 minus 2. Oh, they're giving us points they want us to use. Sorry. So remember, y2 minus y1. So here is, trying to figure out, it doesn't really matter, I guess. We'll call this 0.1 and we'll call this 0.2. So this is x1, y1. This is x2, y2. So if we look at y2, we have negative 1. And y1 is negative 2. And then we have x1, x2. So our, oops, x2 minus x1. What am I doing? Writing it all backwards. So now we're going to take this x value, negative 2, minus this x value, negative 6. I'll be careful here because both the top and the bottom get switched. Negative 1 plus 2 is 1, right? That's what we are expecting. It's going up by 1. And negative 2 plus 6, this is actually going up by 4, right? It's easiest to see from 2 to 6, it's going up by 4. So this is 1/4. So you can find it by looking at the table. You can find it by subtracting points. You can use any 2 points on the line as long as you keep it consistent. So we could have called this point 0.2 and this point 0.1 and still found the same thing. All right, so we did that. Try this check on page 195. Remember, change in y divided by change in x. So figure out what is our change in y here. Then find your change in x. And then simplify. So if I'm finding my change in y, I'm really thinking -1 minus 3, right? And if I'm looking at my change in x, I'm thinking -7 minus 1. So this is really, did you get -4 here and -8 here? If they're both going down, if I have -4 divided by -8, it's really going to be positive, right? And if I divide them by 4, I have 1/2. If you're looking at a graph, like if you just peek up over here, if this is going down, it's going down to this way, and that would make a positive slope, right? So it makes sense that this has a positive slope if as y goes down, x goes down as well. Down and to the left is a positive slope. All right. Let's look at slope formula, which is kind of what we just used. Y2 minus y1 equals x2 minus x1. This is a fancy way of finding the change in x, or the change in y, and then the change in x for any 2 points. So sometimes we're not given a graph, but they're giving us a graph here. So they're giving you these points, 1, 3, and 5, 6. So here they took y2 minus y1, so 6 minus the 3, and then they divided by x2, which was 5, minus x1, which is 1. So 6 minus 3 is 3, 5 minus 1 is 4, so the slope of the line is 3/4. So we've practiced this before. Hopefully it's not too tricky. Let's do this example and check your understanding real quick. So plugging in these points, they're giving us these points. So we're taking y2 and putting it here. We're taking y1 and putting it here. See y2 and y1? And then we're taking x2 and putting it here, and x1 and putting it here. Then we're simply saying 3 minus 2 is 1. And -4 minus 1 is -5. So 1 over -5 is the same as -1/5. Remember, this is also equal to -1 over 5. That is an important understanding for you to have as you move forward, that we can put the negative sign in front of the fraction. We can give it to the top, the numerator, or we can give it to the bottom, the denominator. If we gave it to both, it would be positive, because negative divided by negative is positive. So the slope of the line is -1/5. So here, they're showing you that it doesn't matter what you assign to it. So here they switched it and called this point 1 and this point 2. So if you take that and say 2 minus 3, you would get -1. And here, if you took 1 minus -4, remember this becomes a +5. So either way, you will get -1/5, as long as you're consistent with what you assigned your points to. So find the slope, use the slope formula, right? y2 minus y1 all over x2 minus x1. If it helps, write out, call this point the first point, x1, y1. Call this point the second point, x2, y2. And then plug in these numbers where they belong. Go ahead and try this out on page 197. You should get pretty proficient at this. Y2 is -4, minus Y1 is 2. X2 is 5, minus X1 is -3. So -4 minus 2 is -6. This becomes 8. So we would simplify and it would be -3/4 if we divide them both by 2. Is that what you got? Hopefully you're getting there. All right, we've gone through 4 examples today. The next little bit is just 0 and undefined slope. So I think, well, we might as well fly through here because you've seen this before. Remember, horizontal lines have a slope of 0. This is 0 fun. Vertical lines have an undefined slope. Remember that greatest curse word that ever was in math? Falls off the cliff. We've learned that and reviewed that. So, if we were to find this using the points, they're giving us this. So, y2 is 4. y1 is also 4. x2 is -3. x1 is 2. So 4 minus 4 is 0. 0 divided by anything is going to be 0, but just humor me here. -3 minus 2 is -5. So 0 divided by anything is 0. So the slope of the line is 0. So we're just practicing here. So we have y2, 5, minus y1, which is also 5. So our change in y is always going to be 0. And then here we have 2 minus a -4. So this is going to be 0/6, which is still 0. All right, so we just need to know that a slope of 0 is 0 fun, a horizontal line. Good morning. Sure. Alan? Ellen, Mom needs to talk to you, I guess, maybe? In the office. Sorry, that was not clear, was it? All right. Same thing here when we're looking at undefined. Our change in x is going to be 0. So that's why when they plug in here, the top, it has a number and the bottom is 0. The slope is undefined because we cannot divide by 0. So we're assuming that this is going to be undefined, but let's look at how we would do it. 8 minus 3 all over -2 minus -2. So this is going to be 5/0, right? We call that undefined. So as you start on page 203 today, keep that in mind that some of these slopes may be 0 or undefined, but not until you get down to 4, 5, and 6. So you're going to do 1 through 7. I know you probably don't have time for all of those, but give it a good go. The next couple days we'll be practicing for the quiz. We'll probably take the quiz on Monday. Maybe Tuesday. I do want you to practice quite a bit. But this first quiz is really just about finding the points and so understanding how you would label points on a graph, plotting things on a graph. proportional relationship. So if it doesn't go through 0, things might be changed. Slope and rates, and finding those slopes.